So good evening, all of you. So today we'll look at the interview questions on data cleansing part. So why we have to do data cleansing or data preparation? So generally in data science project, we go with collecting the data, next we're going to prepare the data. We're going to looking for insights. Then we're going to create the model. Next, we're going to see for results insights. If you not prepare the data, and these steps are not possible. So that's why we have to do data preparation before we go for it. What are the factors going to influence the output of a results output, let's say. So if data contains missing values and outliers, so your expected output does not have much power to draw inferences about your results. So in data preparation, what we have to do? So we have to treat this missing values as well as outliers. Am I taking assignment sheet? And your data also contains duplicates. And you have to change the type, and you have to change the categorical variables into dummy variables. So how we can identify the outliers? So we can identify outliers by using box plot. And by using Z-score. And as per Wins-Riser, if the data beyond 3.5 sigma, we're going to treat those values as outliers. Greater than 3.5 are outliers. So what are the methods we use to treat these outliers? So one method is 3R technique. So which contain retain, rectify, and remove outliers. So another method is Wins-Risation. And third one is trimming. So here we're going to retain the outliers in our data set. We're going for do analysis directly. Here we try to treat this outliers. We're going to rectify them by using different methods. We try to bring these outliers to standard scale of other data points. Here. Or else we're going to remove these outliers. Before going for remove, make sure that you are not losing any information from your data, or else your data should not become biased. So here, after removing, data should not become biased. So in Wins-Risation, so we're going to consider 95% of data. We're going to assign alpha, the confidence level 5%. If outliers are more than this 5%, we're going to remove them in Wins-Risation. In another way, we're going to treat these outliers For example, you are having a data set called 1, 2, 3, 4, 5, 6, 7, 8, and 20, 22, let's say. So this is being outlier. So in winsorization, what will happen? They're going to take the second highest number. Our data set is 8. We're going to add 1 to it, and it will become 9. Then it is not going to be act as an outlier. So this is one method to treat outliers in winsorization. Trimming is like removing the outliers. And again, make sure that your data should not be biased after removing or after trimming the outlier. Why we have to change the type of elements in the data. So for example, let's say I have a data, say 1, 2, 3, 4, and mistakenly someone entered this value as a character. So in this case, if I want to perform any operation on this vector, let's say I want to find out mean of y. So it will show any value, null value, because type is not matched with other elements. So we have to change this type, let's say character to integer. And numerical to character, and integer to float. As part of data preparation, we have to look into the structure of the data, and we have to identify what type that particular parameter is. Then if required, we have to change the type from character to integer or numerical to character. Let's say, for example, in case of date, so let's say 24/02/2021. So I want to convert this into a numerical value. Let's say it's going to be in date format. So first I'm going to convert, or else I want to convert this into factor if dates are repeated many times, or else my data contains the attendance of the employees which are attended same day. So I have a data for 1 week. So I have to convert this into factor. Instead of date, I'm going to convert this into factor. So how I can do it? So I'm going to convert this date to character first by using as.character. I'm going to take my data. After converting to character, I'm going to convert this into as.factor. Then it's going to be give the factors of this stage. Okay, it's going to be give in such a way how many levels are there in my date. let's say 2020 and 2019, 2021. This is level 1, level 2, and level 3. This is how typecasting is going to be useful while you are preparing the data. What other anomalies the data can be contained? So data can contain a duplicate values. So we have to remove these duplicate values. So we can, have a question that how a duplicate values can be created in a data. How duplicates are created. So duplicates can be created. For example, if you're going to visit the movie same time, in a day you're going to visit the same movie for 2 times. Then it's going to be one duplicate one. Another example, whenever you're going to request for OTP for money transfer, in some cases, you're going to get same message, same OTP at 2 times. So we're going to remove this duplicate and we're going to keep only one value. So how we can check duplicates in R? How we can detect duplicates in R? So there is a function in R called duplicates. So this function will identify the duplicates in data. So how we can able to execute this one? Simple. You call duplicates and call your data set. Then it will show how many duplicates are there in your data set. Then how to find distinct values in data. So now we saw how we can able to check for duplicates and we can check for the unique values. So again, function is distinct and you have to take the data here. So it will show distinct values in your data. Next one, what are missing values? So missing values are null values, in some cases wrongly entered data, so here there are some methods how this missing data is going to be created. That is called MCAR, missing at completely at random. And MAR, missing at random. And another one, MNOR, missing not at random. For missing completely at random, these values, let's say I'm going to take a weighing machine as an example. So I'm going to record the weights of the players in a team. Let's say I have player 1, player 2, player 3, the height and weight. Let's say I'm only recording weight. So I recorded for, let's say, first 3% I recorded correctly. Let's say 50 kg, 60 kg, and 70 kg. Then there is a problem in my weighing machine. Then my results, the output of this weights of other players is become very random, very ambiguous. So I'm going to get, let's say, 200 kg, and I'm going to get 2 kg. Randomly, I'm getting these values. Let's say 25 kg, 1000 kg. So these values are called the values which are missing completely at random. This is one criteria where we can able to see these missing values. Another one, missing it randomly. I'm going to take same example in a different way. So I'm going to keep this weighing machine on hard surface at the first, very hard, and I'm going to record these weights. Here. P1, P2, so on again. So I recorded for first 3 people. And later I changed this position to soft surface. Then whatever results I'm getting are going to be changes to its exact values, or else it's going to be deviated from its true scale. Let's say I'm going to get 66 instead of, let's say, 60 kgs, and I'm going to get 70 and maybe 200. So on these conditions, again I'm going to get missing values randomly. And this one, missing not at random. For example, this mission we are using for a long time because of wear and tear. Whatever results is giving is very different. About which surface it is, okay, or where it is kept, but because of wear and tear, whatever the values it's giving, it is not at random, but it gives continuously wrong values, list of missing values. So how we can treat missing values? So by using imputation methods, so we can treat this missing values. Missing values. So in general, we're going to remove all missing values. So we are going to remove them. So there are disadvantages with this one and advantages as well. If you're going to remove this missing values, you're going to left with a complete data. The advantage is right here. Page is you are going to left with complete data. Complete data without missing values. And disadvantage is due to deleting these missing values, your data can be biased. Data can be biased. So what is the problem with the biased data? Why not biased data? What is the problem with it? So if my data is biased, most of my data is going to be talk about only one quality. One quality. It's going to be concentrate more on the biased side. unbiased features. So our results insights and results are going to be biased again. So before we're going to get a decision to remove the missing values, we have to look is going to be biased or not. If it is not biased, then you can remove your data and you can go for the analysis directly. And though after deleting these missing values, your data is not become biased, it is unbiased. After deleting, it is unbiased. Though, what will happen? What will happen to your results or prediction power? Prediction power of your mode. If you remove your missing data, though your data is not become a biased, but you're going to reduce the power. Power of prediction capability is going to be reduces. So removing the missing values is a least preferable method you have to consider. Removing or deleting. What are other methods rather than removing missing values? We can use. We're going to replace this missing values with some parameters, like one is we can replace missing value with mean, median, and variance, standard deviation, so if you want to treat this missing values by using mean, So make sure that there are no outliers in your data. So here another question arises: what happened if you're going to have outliers in your data? What's wrong with outliers? In case of treating missing values. If I'm going to take mean as a measure to treat missing values, outlier going to be influences this mean. So outliers influences the mean. So for example, so I'm having data 1, 2, 3, 4, and there is any missing value. I'm having 6 here and 200. So what is the average or mean of this one? 5, 6, 6, 4, 10, 16, 2, 16 by 1, 2, 3, 4, 5, 6. So nearly 45. So I'm going to replace this one. Here I'm considering outlier. I'm going to replace this with 45. Now I'm going to find out mean again. What will happen to my mean? It's going to be same or it's going to be increases. If you're going to treat this missing value with mean where outlier is present in your data, then again your average is going to be increases. So we should not use mean in case of outliers are present in our data, because outliers going to be influence this mean. So what is outlier? What is an outlier? So outlier is an extreme value, extremely high value, or extremely so if you're going to have extremely low values, what will happen? And if you're going to have extremely high values in your data, what's going to be happen to mean? Of these two going to be influence the mean. So for example, I'm going to draw a curve, normal distribution curve, let's say, where there are no outliers in your data. Then your mean, median, and more rely on same line. It's going to be stay on the single line. Then if you're going to have an outlier, then if you're going to have extremely high values, the distribution is going to be changed like this. then your mean tends to move towards right side, towards extreme side. So if you're going to have extremely low values, what will happen to your distribution? How distribution is going to be look like? So it's going to be look like this manner. And your mean tends to move towards left side, towards extremely low values. So due to this outliers, the mean is going to have fluctuations in it. So we're going to avoid this mean to treat our missing values in case where we can able to see outliers are present. How we can able to solve this one? So mean is not applicable because outliers are present in data. So I don't want to use this mean. So how I can able to rectify this missing values problem? So another measure I can use this median. So median will not influenced by the outliers. So here what is median? So it is a middlemost value. So I'm going to use this median to treat my missing values rather than mean. So when you want to use mode to treat missing values, if my data contains repeated values, if data contains repeated values in my column along with missing values, in the same column, then we can use mode. What is mode? Mode is most frequent value. What are model-based imputation methods? So instead of using mean, median, mode, these parameters to treat missing values, we're going to use the models, the machine learning models to treat these missing values. So one example is regression model, regression imputation. So we're going to use this regression imputation methods to predict missing values. How we can able to do this one? We're going to build a regression model without this missing values in our data first. Then we're going to test for the predicted values. Later we're going to feed this missing data, missing values data. Missing value means it's not only one column, it contains the entire record, entire row. So once we're going to test this data on our regression model, it try to predict the possible outcomes. Then we're going to use these prediction values to treat our missing values. Here what will happen? There is no data loss with this method. Data is not going to be lost. And data will not be biased. Most of the cases, data will not be biased. But you're going to reduce the power of prediction. Another method is Canon Imputation. It's like K nearest neighbor. So in Canon Imputation, we try to find out the smallest distance between the data points. Distance between data. Then we try to find out the relation between these parameters. Then after finding the smallest distance, we're going to replace the missing values with the smallest distance. We're going to estimate the missing variables values. Estimate missing values. Then we're going to replace this missing values with our estimated values. So another method is the maximum likelihood method. This third one, max likelihood. Again, it is similar to Canon. We try to find out the similarity between the data point and we try to find out the minimum possible distance between those variables. Then we're going to choose the variables which are having minimum possible distance, and we're going to use those variables to treat missing values. What is the problem with considering all dummy variables in a data? What is the problem with dummy variables? A model. So if you're going to consider all dummy variables in your model going to be face overfitting problems. You're going to feed too much of data into your model. So that's why it's going to be overfit the model. Then how you can rectify this? So what strategy is being used in case of dummy variables? We're going to use a T-1 strategy while we're going to feed this dummy variables data into your model. You're going to use T-1. It's nothing but if you have 4 dummy variables where D equal to 4, in our model, we're going to consider D-1. We're going to consider 3 dummy variables instead of 4. So what will happen if you're going to consider 3 instead of 4? So you can avoid yourself from overfitting the model. Rectify overfitting. Next, what is normalization? Or scaling? Normalization is a technique. It's a technique to bring the entire data into one scale. One scale. And scaling is the same thing. Normalization. How we can do this normalization? The formula is x minus x max by range. We're going to apply this function onto our data. Then our data is going to be normalized. So that's all for today, guys. Thank you.